All right. Good morning, folks. Let me go ahead and let me start my timer here so I can keep myself on track. But hopefully, you had a chance to watch after watching the video yesterday. You were able to pick up on those ionization reactions. I stressed yesterday in class the importance of you being able to work through those ionization reactions, showing how the ions form, showing then that as a result of those ions forming, they will attract one another, and that's the ionic bond. Showing also, hopefully, you're able to pick up already how we can identify these new compounds that form, the difference in the way that we represent them symbolically, and also in terms of their names. Okay, so that's what we're going to be picking up with today. That's what we're going to be working on today for the most part. And then I would like to start into chapter 9 today as well, in order to, and then give you plenty of practice in naming and naming ionic compounds and writing out the formulas for ionic compounds. So please make sure then that if you have any questions about the ionization reactions, which we will be done with, so we won't we'll revisit that a little bit more. I'll be referencing it, but we won't spend a whole lot of class time going over it. So please make sure you had a chance to work through the homework. I think it was set B from chapter 7. And then get your questions answered. Okay, so you will see ionization reactions on the exam for this chapter. So please make sure that you take advantage of the time to ask about it. Okay. All right. So with that said, then let's go ahead then and let's pick up where we left off with at the end of the video yesterday. Okay, so let me go ahead and let me share the screen with you. We were talking about formula units and what they are, because what the identifying feature of an ionic compound is the formula unit. And this formula unit then represents then the repeated pattern, what's being repeated in the particular ionic compound itself. Okay. So we left off with this particular ionic compound yesterday. We were talking about what the sodium chloride is. We were able to show during the and I won't repeat this for you. We were able to show during the ionization reaction then that the sodium ion then is able to give up its one valence electron to chlorine, and so as a result, then the sodium ion and the chloride ion forms. I think the unfortunate thing about showing the ionization reaction is that the assumption many students make then is that this represents what sodium chloride is. Sodium chloride is simply a sodium ion and a chloride ion together forming the ionic compound. Okay. That is the unfortunate, and there are a few others. Okay, one of the unfortunate consequences of writing out the ionization reaction the way we do. However, once at this point, we don't quite understand then that what we see with the ionization reaction, though representing one atom of sodium and one atom of chlorine when they interact with one another, on a macroscopic level. So that's the microscopic view. That ionization reaction is that microscopic view of what happens during the course of the reaction between sodium and chlorine. But we have to make sure we think of this on a macroscopic scale. And that is when we react sodium and when we react chlorine, we're not just reacting one atom of sodium and one atom of chlorine. We are reacting actually many sodium atoms, many chlorine atoms together to form then a compound that we refer to as sodium chloride. And I think I think we had we touched upon that I think on Friday of last week. And so what you need to make sure you keep in mind though, but like I said, the unfortunate consequence of the ionization reactions is many students think then that it's just single atoms interacting with one another, single atoms exchanging electrons and single atoms forming these single compounds. And so that's not the case. Okay? We have to remember, I was telling you back in the first semester, we have to be able to think both on a microscopic level, what's happening here, in this case, at the atomic level, and be able to translate that out into the macroscopic level. And that's what we're seeing here. And so what we see here then is when we take a look at this, the sodium chloride, the compound sodium chloride, is actually made up of many sodium atoms, sodium cations, and many chloride anions interacting with one another. So if you can imagine what we have here, and this is the cube of sodium chloride. So this is a salt cube that we see. You take your salt shaker and you shake out all the salt, and you see then that the little salt crystals are little cubes. Okay? And if you look at, so that's the macroscopic view. Okay? But if you look at the microscopic view, what you're going to see then is that you're going to see then sodium ions and chloride ions interacting with one another. And if you notice in a three-dimensional pattern here, network here, we have then an alternating pattern both along one axis, so along the x-axis, the y-axis, and here the z-axis, because this is a three-dimensional structure, we have an alternating pattern of sodium ion, chloride ion, sodium ion, chloride ion. Okay, so we see that pattern repeat itself, not only in two dimensions here, which is where we left off with yesterday. We took a piece here and we just cut off the top layer. So we took the top layer and we examined that. We would also see that repeating pattern of sodium ion and chloride ion, which leads us back to what we have here, okay, which is what's represented here. This is what we refer to as the formula unit. Okay? Within a salt crystal, within a cube of sodium chloride, okay, we will always get these two ions repeating, those two ions being repeated over and over again, not only along one dimension, one direction, but in two dimensions, but not only in two dimensions, but in three dimensions. Okay? And so we refer to this then as the formula unit. Okay? That is the formula unit, and we see that not only with sodium chloride crystals, but we see that with other types of ionic compounds as well. So let me go ahead and share with you then other ionic compounds, and you'll see that. Okay, let's take a look at let's say barium bromide and barium chloride. Okay, so we have BaBr2 and BaCl2, and I give you a very simple view here of two other ionic compounds. Both of them are made up of barium and one of the halogens. Okay? All right. And so if you take a look at this here, okay, we have this repeating unit right here. The repeating unit for the barium chloride ion, the barium chloride compound, is this repeating unit here, where we have then barium being attached to two chlorides, and we see that unit repeat here and here. So we have four of those repeating units. Those are the what we refer to as the formula unit for barium chloride. Okay? So these repeating units that we can write out then as their formula. Okay? That the unit that is always being repeated. So in every single part here, we see then barium attached to two chlorines. Okay? And again, I've kind of highlighted here, but you can see that happen. So that's the unit that's being repeated here. The unit being repeated in the barium bromide crystal, if you take a look at it, barium and two bromides. Okay, so we see that there. We see barium and two bromides here. Okay, barium and two bromides here. Okay, and so we see that pattern repeat itself here as well. Okay, so we refer to these repeated units. We refer to these repeated units here as the formula unit. The formula unit for a ionic compound. Okay, so that formula unit is what's always going to be repeated, and so we have to make sure then that we can indicate that. And when we write out the formula, for an ionic compound, what we are representing then is this formula unit. So whenever we refer to the chemical formula, okay, we are referring to the repeated units, the repeated parts of the ionic compound. And the repeated parts then will be made up of a cation, cations and anions. Okay? All right. So for example, with sodium chloride, okay, sodium chloride, remember, the compound, when we talk about ionic compounds, it's not only made up of one sodium ion and one chloride. This is made up of millions upon billions, and that's within just a very small grain of salt. You have billions upon billions of sodium cations and chloride anions that are associated together. But what do they all have in common? They have this repeating unit right here, sodium ions and chloride. So we refer to that then as the formula for sodium chloride for that particular ionic compound. Okay. For this particular compound here that we call barium fluoride, okay, what's being repeated here? The repeating unit here then is going to be then the barium ion with two fluoride ions. So this is going to be very much like the barium chloride and the barium bromide that I shared with you on the previous slide. Okay, and so when we write the formulas, for an ionic compound, we only want to indicate the ions that are being repeated. We want to indicate which ions are being repeated, and that's it. So we don't want to write out the whole crystal structure. We only want to indicate the ions that are being repeated within that particular compound. Okay, so that is what a chemical formula is for an ionic compound. Now we're going to define the chemical formula for molecular compound a little bit differently, but for an ionic compound, the chemical formula represents then the repeated unit. And the way that we say that then is that it is going to be that, and the way that we can more accurately say that is that we have the smallest representative unit for that particular compound, for that particular ionic compound. And the smallest representative unit is that particular unit that is constantly being repeated in the compound itself. Okay. All right. So make sure you keep that in mind. That's how we define a chemical formula for an ionic compound. Okay? All right. So how do we go about determining these chemical formulas? Well, one way is through the ionization reaction. Okay. So we already saw how we do that. We see how we can determine then the formula for an ionic compound by writing out that ionization reaction. Not the most efficient way. It's a very detailed way to do it, and it is a way that helps us to understand how the ions form, how the bonds form. Okay? But it takes a lot of work. Obviously, what we went over in class yesterday and what we went over in class on Friday, your homework that you did, it takes a lot of work to write out the ionization reaction just to simply get the formula. So if our goal is to get the formula, we need a simpler way of obtaining that formula. We don't have a way that we do not need to have to go. We don't have to go through the whole process of writing out the Lewis dot structures and showing the ionization reaction. Okay? The shortcut way then, the way that we're going to approach this is going to depend on one very simple fact. Okay, one very simple fact. I'm sorry, a couple of simple facts. The first one is that we have to be able to recognize then that the ionic compound that forms is going to be always between a cation, a metal atom, and a non-metal atom. That we have to recognize first. Okay? An ionic compound will never form between two metals. An ionic compound will never form between two non-metals. An ionic compound has to be made up of cations, which are metal atoms, and anions, which are non-metal atoms. Okay, and so that's the first thing we need to make sure we do in trying to obtain the chemical formula for a compound, for an ionic compound. We have to recognize that it has to be made up of a metal and a non-metal. The second factor that we have to make sure we keep in mind as we go through this is that the charge, you remember, has to be neutral. For an ionic compound, the charge has to be neutral, which means then the charge on the cation has to be balanced out by the charge on the anion. So we have to have enough cations and enough anions so that the charges balance out. That's the second thing you have to keep in mind as we go through this. Okay, so let's take a look at our example again of sodium chloride. Okay, all right. So the very first thing we need to make sure we look at then is that with sodium chloride, then do we have a metal and do we have a non-metal? We absolutely do. Sodium here is a metal, okay, and sodium then will be our cation. Okay, and chlorine here is our non-metal, and it will be the anion. So therefore, the metal, remember, will always be the cation. Metals always form the cations. Non-metals always form the anions. Okay? And so it's always going to be a cation with an anion, a metal with a non-metal. So far, this formula is correct. Okay? So far, this formula is correct. They can go together. Okay? The second thing we have to recognize then is, do the charges balance out if we have one sodium ion with one chloride ion? Do they balance out? Well, this is where you have to go back and remember, we said the charges have to balance out. That means then you have to be able to identify, and this is what we did early on in this chapter. Okay? You have to be able to identify the charge on that particular atom. So if you were given sodium, you need to be able to recognize then, and if you can't do this, then go back to the ionization reaction that showed you how to do this. You have to be able to recognize and remember then that the sodium ion, when it forms, has a 1+ charge. Now, how would you do that? Okay? Is there a way that you can obtain that without having to write out the whole ionization reaction? The answer there is yes. Okay? What you have to remember then is sodium is a 1A metal. Okay? Sodium is a 1A metal. And as a 1A metal, it has then one valence electron. Okay? And if it has one valence electron, remember, it is a metal, and it is a representative metal. So what it wants to do, and maybe I'm sorry, let me write this out because I want to make this clear. It has one valence electron. Okay. And as such, okay, and as a representative metal, in order to become a noble gas, in order to obtain the noble gas configuration, it has to lose that one electron. Okay? And if it loses that one electron, it ends up with a positive one charge. Now, you can either, hopefully you have it memorized at this point, okay? And hopefully you will also see that all the 1A metals, all the alkali metals will always become a cation with a 1 plus charge. All of the alkaline earth metals, all of the 2A metals will always become a cation with a 2 plus charge. Okay? And this is going to be true for all of the representative metals. Okay? So that means then 3A metals and the couple of 4A metals as well. Okay? All right, so you got to make sure you keep that in mind. Okay, and then what you have to be able to do is you have to remember the charge on the chloride ion. Okay, and again, how do you do that? Okay, well, chloride is a 7A non-metal, which means that it has 7 valence electrons. Okay, which means that, and I'm sorry, let me go ahead and let me squeeze this past here. Okay, which means then, in order for it to obtain the noble gas configuration, it has to gain 1 electron, okay, and as such, then it will end up with a negative 1 charge. That's how we know that chlorines always will obtain negative 1 charge. Okay? Now, there is a shortcut to doing that as well. There is a shortcut method that you can use to do this as well. So with the metals, their group number will tell you how many electrons are lost and thus their charge. Okay? With the nonmetals, okay, their group number can help us. Okay, so for example, then let's take a look at the 7A, which are the halogens. Okay? Now, 7A means then that each one of these elements then have 7 valence electrons. Okay, they have 7 valence electrons, which means then, in order for them to become a noble gas, they all have to gain 1 electron, okay, to get to 8. Okay? And therefore, then they will always have a negative charge. Okay? All right, so that means then for all the halogens, you have to add 1 more electron. Okay, there's 7A, which means then 7A, they're right next to the noble gases, which means that they have to pick up 1 electron. Okay? For the 6A nonmetals, okay, they have 6 valence electrons. Each one in the 6A has to pick up 2 electrons in order to become a noble gas. Okay, and then therefore then they will end up with a 2 minus charge, okay, a 2 negative charge. Okay? So 6 plus 2 will get you 8. 7 and 1 more will get you 8. Okay? So what we're doing is we're trying to get to the noble gas. Okay? So continuing on this pattern here. Okay, for the 5A nonmetals, okay, they will have then 5 valence electrons, okay, which means then they need to gain 3 more electrons, and as a result, they will get a 3 minus charge. Okay, so the simplest way, and this works for the 4A for carbon, for the 4A nonmetals as well. Okay, so the simplest way to think about this then is the group number. If you subtract the group number from 8, okay, you will get the charge on the nonmetal, charge on the anion. Take the group number, subtract it from 8, and you will get then the charge on the ion. Okay, group number for the nonmetal. This only works for the nonmetal. Okay, and for the 5A, subtract that from 8, and you get the charge on the nonmetal. Okay? So this is a little trick that you can use to help you memorize then the charges, but you got to make sure you know how to identify the charges on the different ions in order to do what is next. Okay? You got to be, all that was just to be able to show you then that, remember, these, when the compounds come together, okay, the charge has to be 0. The charge has to be 0. And the only way you can determine then whether the charge is going to be 0, that you have to make sure then that you know what the charges are on the individual ions. Okay? And so for sodium here then, if we have 1 sodium ion, that's what this number 1 stands for, and 1 chloride ion, a +1 and a -1 will get you 0. So when you have 1 sodium ion, 1 chloride ion, the charges cancel out, then you're fine. And that will give you the formula for the ionic compound. Okay. First thing you have to do, identify whether you have the correct atoms. Okay, you have to have a metal atom and a non-metal atom to form an ionic compound. Second step then is you got to figure out the charges, because the charges have to be 0, and so you got to be able to practice that. Okay, so make sure you can practice that, you guys. If you don't if you can't see it right away. Okay, so please make sure you practice that, and then come by and see me if you need any extra help. But let's practice it right now. Let's do a couple right now, okay, and let's work through this together. Okay, all right. So let's take a look then at the first one here. We're going to determine the formula for the compound that forms between magnesium cations and chloride anion. Okay, so first thing we want to do is we want to ask ourselves, do we have then a metal and a non-metal? And the answer then is yes. Magnesium, okay, magnesium is a 2A metal. Okay, chloride comes from the chloride anions, comes from the non-metal, and these are the 7A non-metals. So yes, the compound will form. A compound can form. Okay. All right. And so the next question then is, what is the magnesium cation? And so what you need to be able to do is you need to be able to write out the magnesium cation, because that's what forms. Okay. So the magnesium cation is going to be formed from the magnesium atom. Okay. Magnesium is a 2A. The neutral elemental in magnesium is a 2A metal, because the 2A metal, which means that it has 2 valence electrons that it needs to lose. And once it loses those 2 electrons, then it becomes that cation. So you have to be able to write out the symbol for that cation. And if you, again, that was the discussion from the previous slide. If you can't, if I give you this particular metal here and you can't remember how to do this, write out the ionization reaction. Otherwise, if you memorize it, it becomes a lot easier. Okay? All right. So we have then, that's the magnesium cation. The chloride anion is going to be Cl minus. And if you notice here, and in the previous example, we don't write the Lewis dot structure. We just write down the charge of each one of those atoms. Okay? All right. So please make sure you keep that in mind, and make sure if you cannot, if from the name here, you can't get to the symbol here, you got to make sure you practice it and then come by and see. Okay? All right. So the next step then is to ask yourself, okay, this one magnesium cation has a 2+ charge. Okay? This one chloride ion has a 1- charge. Okay? So therefore, when you add those together, when you add this charge to this charge together, will you get 0? The answer is no. You won't get 0, because you'll get then a net charge of +1. And we can't have that. Remember, an ionic compound has to be neutral. So what do we have to do? We need more negative charge. So if we had 2 of them, okay, then the charge would be 0. Are you guys okay with this? So therefore, then we need not just 1, but we need 2 chloride ions in order to form the ionic compound. Okay. So therefore, the formula then for this particular compound is going to be 1 magnesium, okay, and 2 chlorides, and that's how we indicate that. Okay. So let's take a look at the formula here. So that's the formula for this particular compound. Okay. All right. And if you notice here, I didn't need to write in the 1. If there's only 1 of that particular ion, you can leave it out. It's assumed to be a 1 if there's no number there. Okay. And I indicate then the 2 that we need, 2 chlorides that we need, by using the subscript down here. Okay. So that's the first thing. The second thing you should notice then is, in the formula, I leave out the charges. We do not write the charges in when we write out the formula for the compound. The reason for this is that the compound is not 2 individual ions, okay? Or here in this case, 3 individual ions. It is one unit in which the bond then is formed between these two ions here. Okay, so the bond is formed between those 2 ions and the 1 magnesium ion. Okay? And so we don't need to write in that charge, because this compound here is no longer a charged compound. It's neutral. That's the reason why we do not write in the charges there. Okay, so for the formula, you indicate the number of each one of those ions by using what's called a subscript. Okay, so those are the subscripts. And then secondly, we leave out the charges. We do not write in the charge, and that's to clearly show then that the ionic compound itself is a neutral compound. It doesn't have a charge. Okay. All right. Let's go ahead then. Let's do the same thing for the next one. Okay. All right. So for the next example here, okay, we have the lithium. They're asking us to, does a compound form between the lithium cation and the chloride anion? Okay, so does an ionic compound form between those two? And the answer there is yes. Lithium is a 1A metal, okay, and chloride again is a 7A non-metal. So we have a metal and a non-metal right here. So they will form, right? So let's go ahead then. We got to write out the formula for the lithium cation. The lithium cation being a 1A metal will be lithium atom with a 1 plus charge. Lost 1 electron. Okay. The chloride we already see up here, okay, it's going to be then Cl with the minus charge. Okay. So the question then is, will the charge balance out if you had 1 lithium, okay, and 1 chloride? And the answer there is yes. A positive 1 and a negative 1 will be 0. So therefore, the formula that forms between these two, the formula that represents the compound that forms between these two ions is going to be comprised of 1 lithium and 1 chloride. Okay. So therefore, with this particular compound here, we see then, the charges then will balance out with only 1 chloride and 1 lithium. And that is the compound. That's the formula for lithium for this particular compound here. Okay. All right. Let's do a few more. Let me go ahead and let me save this. Okay. Now let me clear this out. Let me open up my whiteboard and let me. I'm going to do a one more for you, and then I'm going to ask you to do a couple. Okay. So let's go ahead then and. Okay. Let's see what happens then. Let's take a look at the. Okay. All right. Let's see. Let's take a look at the compound that forms. Okay, between, and I'm just going to write it in front for you, between the potassium. Okay, potassium cation. Okay, and the nitride anion. Okay, let's take a look at if a compound forms, what will the formula be for the compound that forms between these two ions here? So first of all, will a compound form? Yes, you have the metal here. Okay, you have a 1A metal here, and then you have then a 5A. I'm sorry, a 5A non-metal here. So an ionic compound will form. There's a metal and there's a non-metal right there. Okay. All right, next thing we need to do, let's write out the formula for the potassium cation. Okay, potassium cation is going to be a K plus. Okay, the nitride anion then is going to be an N with a 3 minus. Again, if you cannot get those formulas, the symbols here for the nitride anion and the potassium cation, you guys got to practice it. Come by and see me and I can help you with that. Okay. All right, next question then is, will the charges balance if we have 1 cation and 1 nitride? Okay, well, obviously not, because this is a 1 plus, okay, and this is a 3 minus. Okay, when you add those together, you are not going to get 0. So how do we get 0 then? If we had 3 of these, okay, if we had 3 of those positive charges, okay, then we will have then a net charge of 0. So therefore, keeping that in mind, let's go ahead and write out the formula for this particular compound. We need 3 of these potassiums, okay? And so we're going to indicate that with a subscript of 3, remember? So make sure you keep that in mind. We only have 1, so it's implied to be 1, so we just go ahead and we write down the nitride right there with a subscript of 1. We leave out the charges, and we have then the formula, the compound that forms between those two atoms, okay? All right. Let's go ahead then and let me do one more for you, and let's and then I'm going to ask you to do one. Okay. Okay. What about what's the formula for the compound that will form between magnesium by the magnesium cation, okay, and the oxide anion? Okay. Let's go ahead and take a look at the formula for the compound that will possibly form between these two ions here. Okay, so first of all, will a compound form? Yeah, magnesium is a 2A metal. So we have a metal, and oxide here is a 6A non-metal. Okay. So we have a metal and we have a non-metal. Yes, an ionic compound will form. Okay, now with that taken care of, let's write down the formulas. Let's write out the symbols for each one of these ions here. For the magnesium cation, the symbol then is going to be Mg2 plus. Okay. For the oxide anion, it's going to be O2 minus. Okay. So those are the ions. Those are the symbols for the ions. The last question then is, will the charges balance out if you have one of each? Okay, well, let's take a look at this. So this is a 2 plus. Okay. This is a 2 minus. So if you add those together, you will get net charge of 0. So you have one magnesium, one oxygen, one oxide, okay, and the charges will balance out. So therefore, go ahead and write this out. Magnesium, subscript 1, that means we can leave it out. Oxide, subscript 1, and then we can just write that way. This then is the formula for the compound that forms between magnesium cations and oxide anions. Okay. All right. I would like you to try one right now. So on your paper, I would like you to show me then, write out the formula that for the compound that forms from the aluminum cation and the phosphide anion. So I would like you take about 2 minutes right now. Take about 2 minutes, write out the formula. Now, again, do it this way for now. I think I would like you to show me on your paper right now. Do it the way I show you here. At some point, hopefully by tomorrow, you don't have to do all of this. You can think this part in your mind and write out the formula. Okay? But for right now, I'd like you to show me on your paper, show me exactly how the aluminum cation, the phosphate, the formula for the aluminum for the compound, the forms between the aluminum cation and the phosphide anion. Just take about 2 minutes to show me how that forms. Okay, go ahead, get that done. Okay, let's take a look at it. Let's take a look at it. Okay, so check your paper, you guys, and compare the answers. So aluminum cation. Now, aluminum is a 3A metal. So first of all, will a ionic compound form between these two here? The answer should be yes, because this is a 3A metal. Okay. Phosphide then is right underneath nitrogen. It's a 5A non-metal. So we have a non-metal and a metal getting together. And so yes, an ionic compound will form. Let's go ahead then and let's write out the symbol for the aluminum cation. Aluminum cation then is Al3 plus. The phosphide anion then is going to be F with a 3 minus. Okay. All right. Now, last question then. Will the charges balance if we have one aluminum with its 3 plus charge and one phosphide with its 3 minus charge? Will those two balance each other out with only one of each? And the answer is yes. And so therefore, the formula for the compound that forms between aluminum cations and phosphide anion, then it's going to be aluminum, one aluminum ion, okay, and one phosphide ion. So that would be the formula for aluminum for the compound that forms between. Okay, and so just a quick recap here. Then just keep in mind then, what we've done here is we've taken what we have identified here, the 1, okay, for each one of these, okay, and we've just used that as the subscript that we use to place right by the in the formula itself. Okay, so that's why you have to do this analysis here, where you have to try to balance out the charges. Okay, again, at some point, hopefully by tomorrow, maybe even today, you can start doing that in your head. Okay? All right. Now, that even doing it this way here is a bit drawn out. Even doing it this way is a bit drawn out. But what I'd like you to do is, let me go ahead and save this. Okay? But what I want to do then is we want to even simplify this process even more, so that we don't have to write out the charges. Okay? We don't have to. I'm sorry. We don't have to write out the symbols here. We don't have to do this step here where we balance it out this way. So we are adding up the charges. Okay? We want to be able to save a little bit more time. Okay? And there is a simpler method to go about doing this. There is a shortcut way that we can go about obtain the formula for the compounds. Let me go ahead and share that with you. And I'm running low on time, so I'm going to share with you. I'm going to go over it, and then we'll practice it tomorrow. We'll practice it in class. I'm sorry, on the lesson for tomorrow. Okay. The shortcut then requires that you, first of all, you still need to know the charge of the cation and the anion. You have to be able to do that. So you have to be able to do that. Okay. And then what we're going to do then is we're going to we will still be balancing out the charges. Okay. So we still will be balancing out the charges, but the way we're going to balance it out is a little bit. It works. Okay, but you got to be careful with it. Okay, and so what we're going to do then is we're going to use the charges as subscripts. That means basically we're just going to cross the charges, and that's how you want to think about this. And in order to obtain the formula. Okay, so we're going to work on this tomorrow in the lesson for tomorrow. We're going to work on this, but please start taking a look at them. Work out a few of these problems on your own, and then ask your question tomorrow. Okay, in class, make sure you ask it. But we'll pick up with this tomorrow in the lesson. Okay. All right. Have a good rest of your day, folks, and then I will have a good rest of your Wednesday, and I'll see you folks on in class tomorrow. Okay. All right.